Okay guys, we are still in the series of complex numbers, and in this video we're talking about equal complex numbers. Given that we have two complex numbers, z1 and z2. Z1 in a rectangular form, a plus bi, and z2 c plus di. Now z1 is said to be equal to z2, that is a plus bi is equal to c plus di, if and only if a is equals to c and b is equals to d. This means that you can consider two complex numbers to be equal if and only if the real part, which is this a, the real part of the complex number of the first one is equal to the real part of the second complex number, and the imaginary part of the first complex number is also equal to the imaginary part of the second complex number. So that's what we'll be doing here. So we'll be giving you examples on how to do this and how to relate them to one another. So let's get into the first example to make all this really make sense to us. First example, quickly. We're supposed to be asked to find the value of x and y. Find x and y respectively, for which x plus yi over I is equal to 7 plus 9i. We want to solve this quickly. What we need to do in this case is to make this part here. We want to make this part to be in a linear form, where we can now compare the real parts of this side to the real part of this side. Then we can get the value of our x and y respectively. So to do this, we need to rationalize first. So to rationalize this, I will have x yi over I, okay, then times I over I, isn't it? Times I over I, okay, that will be equal to xi plus yi squared over I squared, okay, and that will be xi, I squared is minus 1, okay, so that is minus y over minus 1, and I'll be having minus xi plus y. So this part here has been represented as this. So we want to compare it with what we were given. So in that case, I will be having y minus xi is equal to what? 7 plus 9i. So for us to know if it is equal, that means this y without having I is equal to what? 7, and this one here minus s is equal to 9 because it's having I. So therefore y is equal to what? Y is equal to 7 and minus x is equal to what? 9. Therefore x is equal to minus 9. So that's how to do this first example. Let's see another example to see another way we could see question on this. That's how to solve this question. So let's quickly check another example so we can get ourselves familiar to how to solve questions of like structures. Continue. Now you're asked to find value of x and y in this equation. Given this equation, x into 1 plus I squared, okay, plus y into 2 minus I squared equals to 3 plus 10i. Wow, for all x, y, they are what? They are member of a real number. This is a very simple question, but just have to expand it. Okay, so we have x here. Let's expand this one. So if I'm expanding this one as a power of 2, I will have 1, okay, plus 2i plus I squared, okay. If I properly expand that, I will have y for this one also. I will have 4 minus 4i plus I squared, okay, then equals to 3 plus what? 10i. So let's open the brackets one after the other. So I'll have x plus 2xi minus x here. My I squared here will be minus 1, so that'll be minus x here already, plus 4y minus 4yi. I squared here will be minus 1, so I'll be having minus what? Minus y. Everything is equals to 3 plus 10i. Okay, so obviously s is cancelling s. The way we can see this one, you can see that this one is cancelling this one. Okay, so that one is out. That one is actually out. So I'll have I'll have 2i. Let's bring the one that have I together. This one has I, this one has I. Okay, so I'll have 2x minus 4y. They both have what? I. Then plus in fact this one here, 4y minus y, that's 3y, that's plus 3y is equal to 3 plus 10i. Alright, so it's time for us to compare as an equal complex number. So the one that has I here will be equal to the one that have I here. So I will have what? 2x plus 2x minus 4y is equals to what? 10, because they both have I. Then 3y is equals to what? 3. So we can check from the second equation that y is equals to 1. Putting that here, I will have 2x minus 4 into that's one value of y is equals to 10. So 2x minus 4 is equals to 10. Therefore 2x is equals to 14. If I should bring this one to this other side, okay, that will be plus. Then divide both sides by 2, x will be equals to 7. In that case, we've been able to successfully solve what we have here, and that's how to work with equal complex number. So just make sure that the real part of the first complex number is equal to the real part of the second